Hello guys, welcome to the Doubtlet. So in this video, we will learn how to find the inverse of a given matrix. So here I have already written a 2 cross 2 matrix, that is 5 2 1 3, and we need to find the inverse of this. So let's suppose the name of this matrix is A and we need to find the inverse. So first of all, we will write the formula to find the inverse, that is adjoint of matrix A divided by determinant of A. So first of all, we will find the determinant of this matrix, then we need to cross multiply and subtract. So this will become 15 minus 2 is equal to 13. So determinant of this matrix is 13. Since determinant is not equal to 0, it means A inverse exists. This is the primary condition for a inverse of a matrix to be exist, because determinant here is in the denominator. Now to find the adjoint of matrix, we need to find the cofactor matrix and then we have to take the transpose. So to find the cofactor matrix, what we need to do? We need to remove the column and row of that element and then minus 1 to the power 1 plus 1 multiply by 3. This is minus 1 to the power 1 plus 2 multiply by 1. This is minus 1 to the power 2 plus 1, because second row first column, multiply by 2, minus 1 to the power 2 plus 2 multiply by 5. So this is the cofactor matrix, and if we will solve this, what we will get? We will get 3 minus 1 minus 2 and 5. And if we will take the transpose of this, then we will get the adjoint matrix. So we can write here the adjoint of A. So we will transform the row into columns. So it will become 3 minus 1, this will become minus 2, this will become 5. And if we will divide the determinant by each element, then we will get the inverse. So inverse is 1 divided by 13 multiply by 3 minus 2 minus 1 and 5. And if we will solve this, means this is a scalar quantity, and if we will multiply this, so it has to multiply it by each element separately. So it will become 3 divided by 13, this will become minus 2 divided by 13, this will become minus 1 divided by 13, and this will become 5 divided by 13. So this is the inverse matrix of A. So we can write this as A inverse. Now here we have solved a 2 cross 2 matrix. Now in the next example, we will take the example of 3 cross 3 matrix. So suppose this matrix is B, so we need to find the B inverse. So definitely first we need to find the adjoint of A, adjoint of B divided by determinant of B. So first check whether determinant is 0 or not, because if the determinant of this matrix is 0, then matrix would be not invertible. So we will expand it through first row. So what we will get? We will get 2 minus 0 minus 2. We need to cancel out this row and this column. So what we will get? We will get minus 6 minus 0 and then plus 3. We will get 3 plus 2. So value of determinant of B is equal to, this is 2 plus 12 plus 15. So basically this will become 29. 15 plus 2, 17 plus. So determinant value is 29. Now to find the adjoint matrix, first we need to find the cofactor matrix. To find the cofactor matrix, we will follow this sign convention: plus, minus plus, minus plus minus, plus minus plus. And we have to remove the particular row and column and take the determinant of the remaining matrix. So if we will just take the first element, we have to remove we have to remove this column and this row, and we have to take the determinant of this. So for the first, let me write it again, wait. So this would become minus 1, 0, 1, minus 2. Minus times of, this would become 3, 0, 2, minus 2. And here this would become 3, minus 1, 2, 1. And if we will solve these, so we can write C as, this is the first row. So this will become 2 minus 0. So here it will become 2. So here minus 6 minus 0 and minus sign is in the front. So it will become 6. This will become 3 plus 2, 5. So we have got the first row. Similarly, for the second and third row, we need to eliminate the particular row and column of the element and then solve the determinant of the remaining matrix. So the matrix would be 2, 3, minus 2 for here. So this is minus, this is plus. This would become 1, 3, 2, minus 2, and here minus again. So it will become 1, 2, 2, 1. If you will solve this, so minus 4, minus 7, so it will become 7. So here minus 2, minus 6, this will become minus 8. This will become 1 minus 4 minus 3, so it will become 3. Then for the last row, we will need to find the determinant of this matrix first, then minus times of, this would become 1, 3, 3, 0, and this would become 1, 2, 3 and minus 1. Then definitely this would become 3, this would become 9, and the last element of the last row will be minus, this would minus 1, minus 6, minus 7. And to find the adjoint of this, adjoint of B, because this is the cofactor matrix, we need to take the transpose. So in taking the transpose, this will become 2, 6, 5, this would become 7, minus 8 and 9, and this would become 3, 9 and minus 7. Now to find the value of B inverse, we need to divide the value of determinant 29 to each element of this adjoint B. So what we will get? We will get 2 by 29, this is 7 by 29, this is 3 upon 29, this is 6 divided by 29, this is minus 8 divided by 29, this is 9 divided by 29, this is 5 divided by 29, this is 9 divided by 29, this is minus 7 divided by 29, and this is the final answer for the inverse of matrix B. So this is how we can find the inverse of any matrix of any order. But remember, inverse can only be found for a square matrix only. So I hope you would have liked my solution. Then please share it with your friends, and we have also made a calculator to find the inverse of any matrix of any order, but it should be a square matrix, and I will put down the link of that in the description box below. Thank you very much. So I hope you got the concept what I am trying to deliver. So if you like this video, please hit the like button below, comment on this video, give the feedback so that we can improve upon the quality and the content of the solutions and the questions that we are providing. And please share it with your friends so that they can also learn the basic concepts and give proper feedback. And in the end, if you want to ask any other doubt, then visit my website, that is, link is given below in the description, and you can also ask your doubt by posting them in the comment box below. Thank you very much.